Hello friends, I am from chemistry faculty of QLS Academy. Today we are going to start a new chapter, carbon and its compounds. In today's lesson, we are going to learn how the compounds of carbon are formed. Hope you will enjoy today's lesson. So now let's get started with our today's lesson. Out of all the non-metals, carbon is the far most versatile and peculiar non-metal. हम जो भी चीज़ यूज़ करते हैं उसमें कहीं ना कहीं कार्बन प्रेजेंट रहता है. From the food we eat to the notebook we write on to the soap we use, carbon is present everywhere. The carbohydrates, vitamins, fats we take in as food all contain a heavy amount of carbon. A major portion of their structure is only carbon. The cotton clothes we wear, the paper of our books and notebooks are actually cellulose, which is again a carbohydrate. The plastic we use to store food items, drinks, to coat electric wires, to make pipes, electrical equipments are all made up of polymers of carbon. There is only 0.02% of carbon in Earth's crust in the form of minerals like carbonates, hydrogen carbonates, coal and petroleum. The atmosphere contains 0.03% of carbon as carbon dioxide. In spite of the small amount of carbon in nature, there is huge importance of carbon in our daily life. Now, let's see the characteristics of carbon which has made carbon so versatile and important for us. By now, you all must be aware of the concept of valency. Atoms combine with other atoms to complete their valencies. In last chapter, we learned that ionic compounds, the compounds formed by combination of metals and non-metals. Ionic compounds were formed by complete transfer of electrons from metals to non-metals. Metals से जब non-metals में completely electron transfer हो जाता है, तब ionic compounds का formation होता है. This complete transfer was happening because it was difficult for metals to accommodate the extra required electrons to fulfill its octet. So, metals अपने outer shells में present सारे electrons को lose कर देते हैं. For example, sodium, instead of gaining 7 electron, loses 1 electron to make its electronic configuration from 281 to 28 instead of making it 288. But it was difficult for non-metals to lose the electrons to have a complete octet. Rather, it was easier for them to take up the extra required electrons to complete their octet. For example, chlorine, instead of losing 7 electrons, gains 1 electron to make its electronic configuration from 287 to 288 instead of losing 7 electrons and making it 28. But carbon has 4 electrons in its outermost shell and it need to gain or lose 4 electrons to attain the noble gas configuration. Or we can say that carbon is tetravalent, means having a valency of 4. कार्बन या तो 4 इलेक्ट्रॉन्स गेन कर सकता है या फिर 4 इलेक्ट्रॉन्स लूज कर सकता है टू हैव अ कंप्लीट ऑक्टेट. कार्बन इज टेट्रावैलेंट. It could gain 4 electrons and form a carbon anion, C4 negative anion. But it would be difficult for the nucleus with 6 protons to hold on to 10 electrons, means 4 extra electrons. Nucleus के लिए हम जानते हैं कि एटम के अंदर equal amount of protons and electrons होते हैं. So, it would be difficult for 6 protons to hold 10 electrons. Or carbon could lose 4 electrons forming a carbon cation, C4 positive cation. But it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons holding on to just 2 electrons. जैसे 6 protons 10 electrons को hold नहीं कर सकते थे, ये difficult task था. उसी तरह से 6 प्रोटॉन्स का 2 इलेक्ट्रॉन्स को होल्ड करना भी एक डिफिकल्ट टास्क है. सो टू ओवरकम दिस डिलेमा, कार्बन नीदर गेन्स नॉर लूजेस इलेक्ट्रॉन्स, इट शेयर इलेक्ट्रॉन्स. Carbon share the electrons present in its outermost shell with other carbon atoms or with atoms of different elements. When electrons are shared between two atoms, the electrons belong to both the atoms and helps both the atom to achieve the noble gas configuration. This method is not only used by carbon but by many other elements to form their different compounds. For example, 2 atoms of hydrogen share their electrons to form hydrogen molecule. It achieves the complete octet of 2 electrons, that is the electronic configuration of its nearest noble gas, helium. This type of bonding is known as covalent bonding. यहाँ पे हाइड्रोजन एटम्स के बीच में एक कोवेलेंट बॉन्ड फॉर्म हो रहा है, because hydrogen has a valency of 1. Now, what about elements with valency more than 1, with valency 2 or 3? Such elements also form covalent bond with two choices. First, they can form a bond with multiple other atoms of the same type or of different types. Like oxygen has a valency of 2. It can either combine with two hydrogen atoms or with another oxygen atom. अब ऑक्सीजन की वैलेंसी 2 है, उसके पास दो चॉइसेस हैं, या तो वो अपनी 2 वैलेंसीज को दो अलग अलग एटम से फुलफिल करे, या फिर ऑक्सीजन एक दूसरे ऑक्सीजन एटम के साथ कंबाइन होकर अपनी वैलेंसी फुलफिल करे. सो हियर यू कैन सी ऑक्सीजन इज कंबाइनिंग विद 2 हाइड्रोजन एटम. यहाँ पे ऑक्सीजन 2 हाइड्रोजन एटम्स के साथ कंबाइन हो रहा है. ईच ऑफ द वैलेंसी ऑफ ऑक्सीजन इज फुलफिल्ड बाय ईच ऑफ द हाइड्रोजन एटम. While here you can see that oxygen is combining with another oxygen atom. अब यहाँ पे बीच में दो बॉन्ड शो हो रहे हैं, means they are forming a double bond. When oxygen combines with two hydrogen atoms, it forms water, H2O. The bond formed between two oxygen atom is called as double bond. यहाँ पे 2 pair of electrons की sharing हो रही है. Similarly, a triple bond is formed between two nitrogen atoms. Nitrogen has a valency of 3, means it requires additional 3 electrons to complete its octet. So, when a nitrogen atom share electrons with another nitrogen atom, they form a triple bond. A bond formed by sharing of 3 pairs of electrons. Nitrogen के पास एक और choice है. It can fulfill its valency by combining with 3 hydrogen atoms. This compound formed by combining 3 hydrogen atom to 1 nitrogen atom is ammonia, NH3. Carbon also forms multiple bonds with many other elements and to itself. And since carbon is tetravalent, it can combine with 4 atoms of different elements or with 4 other carbon atoms at the same time. This is one of the major reasons why we find carbon almost everywhere. The simplest carbon compound formed is methane, combination of 1 carbon atom with 4 hydrogen atoms. Methane is CH4, 1 carbon and 4 hydrogens. Here you can see that at center the blue circle is carbon. It is forming 4 bonds with 4 hydrogen atoms. यहाँ पे रेड कलर के जितने भी सर्कल्स शो हो रहे हैं ये सारे हमारे हाइड्रोजन हैं. The red dots you see here are the electrons shared by hydrogen, while the blue dots you are seeing, they are electrons shared by carbon. Here carbon has 4 shared pairs of electrons. The electrons shared by carbon are helping hydrogen atoms to complete their valency. And in turn, the hydrogen atoms are helping carbon atom to complete its valency. Methane is a major component of biogas and compressed natural gas. The glucose we intake in the form of food is also a carbon compound. We write glucose as C6H12O6. Here you can see how complex the structure is. Carbon at the same time hydrogen, oxygen, carbon atoms के साथ bond form कर रहा है. The valency of one carbon atom is being fulfilled by combined contribution of all the other atoms through single and double bonds. Covalent bonds we discussed just now and the ionic bonds we discussed in last class are the strongest bond in the nature. In last chapter, we saw that ionic bond was holding the oppositely charged ions together. Ionic bond कब form हो रहा था? जब positive और negative ions एक साथ आ रहे थे. Positive और negative ions के बीच में जो bond form हो रहा था, उसे हम कह रहे थे ionic bond. The attraction, or we can say that bonding was so strong that the compounds formed were very strong and hard with very high melting and boiling points. The boiling and melting point of compounds formed by covalent bonding can be said to be lower than that of ionic compound. जो covalent compounds होते हैं उनका boiling और melting point हम कह सकते हैं कि ionic compound से कम होता है, which implies that the forces of attraction between these molecules are not as strong as in ionic compounds. Covalently bonded molecules have strong bonds within the molecule, but the intermolecular forces of attraction are small. Covalently bonded जो molecules होते हैं, molecule के अंदर तो बहुत strong bond होता है, but अलग अलग molecules के बीच का जो interaction होता है वो weak होता है. And this gives rise to low melting and boiling points of the covalent compounds. Since the electrons are shared between atoms and no charged particles are formed, such covalent compounds are generally poor conductors of electricity. In case of carbon, there is exception to both electrical conductivity and melting and boiling points. कोवेलेंट कंपाउंड्स का मेल्टिंग एंड बॉइलिंग पॉइंट यूजुअली आयनिक कंपाउंड्स के मेल्टिंग एंड बॉइलिंग पॉइंट से कम होता है, बट diamond, which is an allotrope of carbon, is known to have the highest melting point for any natural occurring element. Carbon in the form of diamond has a melting temperature of 3500 degrees centigrade. Carbon in the form of graphite is a good conductor of electricity. Diamond and graphite are both carbon only, but they have a huge difference in their physical properties even though their chemical properties are the same. Diamond is the hardest substance known, while graphite is smooth and slippery and soft. The difference in their physical properties arise from the arrangement of carbon atoms in them. Diamond and graphite ये दोनों ही सिर्फ और सिर्फ कार्बन से बने, इनमें और कोई एलिमेंट प्रेजेंट नहीं है, बट इसमें कार्बन का अरेंजमेंट किस तरह से, जब 3D स्ट्रक्चर किसी भी चीज़ का बनता है, 3D में एक स्पेशल अरेंजमेंट कार्बन का किस तरह से है, उससे डिफाइन होता है कि वो डायमंड बनेगा या ग्रेफाइट बनेगा या कार्बन का कोई और एलोट्रोप बनेगा. इन डायमंड each carbon atom is bonded to 4 other carbon atoms, forming a rigid 3-dimensional structure. In graphite, each carbon atom is bonded to 3 other carbon atoms in the same plane, giving a hexagonal array. हम एक हेक्सागोन इमेजिन कर सकते हैं. हेक्सागोन के 6 एजेस होते हैं, तो हम हर एक एज को अगर एक कार्बन इमेजिन कर ले तो दिस इज अ हेक्सागोनल एरे ऑफ कार्बन एटम्स, जस्ट लाइक इन ग्रेफाइट. अब वन ऑफ दीज बॉन्ड्स, इन कार्बन्स के बीच में जितने भी बॉन्ड्स हैं, वन ऑफ दीज बॉन्ड्स इज अ डबल बॉन्ड एंड दस द वैलेंसी ऑफ कार्बन इज सेटिस्फाइड. ग्रेफाइट इज फॉर्म्ड बाय लेयरिंग द हेक्सागोनल एरेज वन एवर वन. एक हेक्सागोन है, वैसे ही और भी हेक्सागोन्स उसके साथ अटैच्ड हैं. अब जब पूरी लेयर फॉर्म होती है तो एक स्टैक्स ऑफ हेक्सागोन्स बनते हैं, तो तब बनता है हमारे पास ग्रेफाइट. Another allotrope of carbon is fullerene. It was first predicted by Japanese scientist E.G. Osawa in 1970. Fullerene is a complete family of carbon allotrope. The first fullerene discovered was C60. It was formed by 60 carbon atoms joined together in the form of a soccer ball. The carbon atoms are arranged in the form of pentagons and hexagons, where no two pentagons share edges. Fullerene C60 is named as Buckminster Fullerene in honor of the US architect Buckminster Fuller, who popularized the geodesic dome design. So friends, this was all for bonding in carbon. Today we learned how carbon joins with itself and other elements. Today we learned another type of bond, that is covalent bond. We also learned about single, double and triple bonds. In next class, we will learn about the different types of compounds formed by carbon. Hope you had fun learning about bonding in carbon. If you have any doubt or need any further information, you can visit the following given link.